When historians describe the year 1887 across the American railroad network, they usually focus on the expansion above ground, the completion of transcontinental routes, the ornate Victorian terminals rising in major cities, the standardization of track gauge that finally unified the nation's railways, and the 163,000 miles of track that connected isolated frontier towns to industrial centres. But the real story, the one that barely appeared in railroad journals, the one that even today sits buried in transportation archives, began beneath the platform levels. It started with a straightforward station modernisation programme. Railroad engineers were instructed to survey terminal facilities across the Midwest and Great Plains for potential upgrades. The goal was practical: assess structural conditions, identify capacity limitations, and determine whether existing stations could handle the projected increase in passenger traffic. But the moment inspection teams began examining the deeper levels of certain terminals, something unexpected happened. They discovered infrastructure that predated the railroads themselves. Beneath the station platforms, at depths far exceeding any known foundation requirements, the crews found ventilation systems and climate control apparatus that didn't match any documented railway construction. Their design was sophisticated, their purpose was unmistakable, and the technology didn't resemble anything in the mechanical engineering catalogues of the era. It didn't even resemble European railway systems as commonly understood. This wasn't mentioned in the public reports about railroad modernisation. It didn't make it into the trade journals celebrating America's transportation progress. But in the internal notes of that year, a quiet phrase appears over and over again. Pre-existing installations, advanced characteristics, construction date uncertain. The official story would later simplify all of this into repurposed mining equipment, converted warehouse facilities, or simply misidentified building remnants from earlier frontier settlements. Nothing unusual, nothing worth discussion. But the inspection photographs from the time, the ones developed in railroad company offices, while America expanded its network at unprecedented speed, show something different. They show workers standing beside air circulation systems embedded in bedrock beneath station floors. Ductwork fabricated with precision far tighter than any sheet metal shop of that era could achieve. Climate regulation chambers that don't resemble any known heating or cooling system, but something more complex, more automated, more fundamentally advanced. And the deeper they inspected, the more the structures stopped looking like retrofitted buildings as we know them, and more like purpose-built facilities that had been constructed, operated, and deliberately obscured before the railroad companies even arrived. At first, the inspection teams tried to categorize everything in the simplest way possible. Old ventilation shafts from previous buildings, abandoned utility systems, debris from pre-railroad town development. But as documentation accumulated and more stations were examined, the inconsistencies multiplied. Why were some of the ventilation systems built with airflow calculations far exceeding anything needed for the stations above them? Why were certain mechanical components shaped with tolerances as if precision manufactured rather than hand fabricated? Why did some climate control networks extend into the bedrock far beyond the footprint of any documented structure? And the question that troubled even the most experienced railway engineers: why were these systems so sophisticated? Railroad stations in 1887 were basic facilities: wooden platforms, simple waiting rooms, rudimentary ticket offices. Yet the infrastructure beneath certain terminals appeared designed for environmental control no contemporary engineer had achieved. Inspection teams quietly admitted among themselves that the precision and integration didn't line up with any known construction company. And although none of them were using terms like automated environmental systems, they were acknowledging something just as unsettling. Someone had built advanced passenger facilities here before. Not simple depots, not frontier structures, fully climate-controlled terminal complexes. If you're finding this investigation compelling, consider subscribing. These mysteries don't fit neatly into official history, and uncovering them requires looking where conventional narratives refused to go. As the documentation increased, so did the silence. Inspection reports became shorter. Descriptions became vague. Photographs stopped showing the most extensive sections of the underground systems. And then certain inspection zones were excluded from the modernization program in late 1887, marked as structurally sound, no modifications required, where needed, and much of what was documented was filed into obscurity. Only fragments remain. Engineering notes, a collection of photographs, and the quiet testimonies of railway inspectors who saw the complete installations before portions of the documentation were restricted. But even from what survives, a pattern becomes visible. Technology too advanced for frontier construction. Design principles too sophisticated for the accepted timeline. Engineering methods that look perfected rather than experimental. Infrastructure that seems to belong to a completely different understanding of building systems. When the inspection teams moved beyond the first recognizable levels beneath the station platforms, the expectations were simple. They believed they would find foundation walls, perhaps some drainage systems, and scattered remnants of previous construction. Nothing unusual, nothing extraordinary. But within months, that assumption collapsed because, instead of a straightforward sequence of building layers, the teams uncovered networks of mechanical systems that didn't behave the way 19th century infrastructure is supposed to behave. The first anomaly was standardization. Each installation, whether found in stations across Nebraska, Kansas, or Iowa, seemed to follow the same engineering specifications, the same dimensional standards, the same design principles. Different railroad companies shouldn't do that. Different architects, different contractors, different construction years. They don't build with identical specifications across hundreds of miles of territory, controlled by competing railways. Yet beneath stations across the Great Plains they did. Ventilation networks from stations on the Union Pacific Line matched exactly with systems discovered under terminals built by the Burlington and Quincy. Climate control chambers maintained the same geometric proportions even when separated by vast distances and supposedly constructed by different companies. It was as if every station was built according to an original master plan, one that no longer existed in any railroad company archive. As the workers investigated deeper into the substructures, the systems became stranger. Beneath the expected foundation levels and utility spaces, they began encountering installations that looked nothing like contemporary mechanical equipment. Much larger air handling chambers, much more complex distribution networks, configurations that seemed too mathematically precise for anything in America's documented timeline. Some systems appeared almost over-engineered. Climate control chambers with perfect airflow geometry, crafted with precision that didn't match the crude fabrication shops of frontier towns. The materials themselves raised questions. Metallurgical analysis conducted years later on salvaged components showed manufacturing techniques that shouldn't exist in 1880s production. Sheet metal with uniform thickness across large panels, riveting patterns that suggest automated assembly, and corrosion-resistant coatings that resembled modern galvanization processes rather than Victorian-era metalwork. And then came the discovery that puzzled even the most conservative members of the engineering community: automated climate regulation. Not simple passive ventilation or coal-fired heating, but sophisticated systems that appeared to maintain constant temperature and air quality without human intervention. Chambers with thermostatic control mechanisms, installations with humidity regulation features, and lower sections with what appeared to be air purification systems that only make sense for facilities designed to operate continuously for extended periods. Yet there is no historical record of any American railroad station having automated climate control before 1887. No patents showing any company achieving self-regulating environmental systems. Nothing that explains why stations in remote prairie locations were equipped with infrastructure that resembles modern HVAC engineering, operating decades before such systems were even theorized. Inspection photographs taken in 1887 and 1888 show this clearly. Workers standing beside ductworks so precisely fabricated that the men look primitive in comparison. Control mechanisms machined so accurately that even today mechanical engineers study the archival images in disbelief. System designs and installations that resemble advanced building automation far more than anything late 19th century America is credited with. But the most unsettling detail was not what appeared in the photographs. It was what didn't appear in the archives. The official railroad construction histories barely mention these subsurface features. Some station diagrams omit the climate control levels entirely. Certain systems are summarized with vague terms like existing foundation structures or previous installations, even though the photographs show they were far more sophisticated than that. The silence is hard to miss. Because if these underground systems truly belong to known railroad construction projects, why weren't they described in detail? Why weren't the advanced environmental controls documented thoroughly? Why were the photographs scattered across different railroad company archives instead of gathered into comprehensive technical reports? Even some of the mechanical components raised red flags. Tolerances too tight for hand fabrication, assembly too precise for field construction, automation too sophisticated for the era. Features that look less like experimental prototypes and more like mature technology. Technology that, according to the conventional timeline, didn't exist when those stations were supposedly built. The deeper the teams inspected, the harder it became to fit these findings into the accepted narrative of American railroad development. Because station by station, the network began to look less like independent construction projects and more like components of a planned system. A transportation infrastructure built, operated, and somehow inherited by railroad companies that never acknowledged its true origin. When the inspection teams pushed deeper into their examination of the subsurface station systems, the discoveries stopped resembling anything that belonged to conventional 19th century railroad construction. What they began uncovering were facilities that didn't match American railway engineering, didn't match European terminal design, and didn't even match each other in their supposed construction dates. Instead, they formed a strange architectural vocabulary, one that seemed to come from a unified building standard, yet somehow preceded everything in the transportation records. The first shock came with the passenger capacity design. These weren't systems sized for the modest traffic levels of frontier railroad stations. They were engineered for facilities handling thousands of passengers simultaneously, air circulation calculated, for crowd densities that wouldn't exist in these locations for another 50 years, waiting areas with climate control appropriate for major metropolitan terminals, and platform-level infrastructure designed for train frequencies far exceeding anything the single-track prairie railroads could support. The capacity wasn't speculative. It was built in, designed, executed with the kind of traffic modelling that modern transit planning wouldn't develop until the mid-20th century. And then came the feature that still puzzles researchers today: the deep-level facilities. Officially, they were later labelled as storage basements, coal cellars, or simply unused foundation spaces, but nothing about them fits typical railroad construction. These were too systematically organised, too carefully finished, and too obviously designed for human occupation, as if they were meant to function as lower-level station platforms, serving trains that ran beneath the surface platforms. Some chambers were large, enough to accommodate multiple passenger cars. Others contained what appeared to be ticket facilities, waiting areas, and even remnants of information boards, all positioned 1 or 2 levels below where trains actually ran. Workers from the 1887 inspections described them in private correspondence as subsurface terminals, not storage spaces but functional station facilities designed for underground railway operations. though no official history acknowledges any American railroad operating below street level outside of major urban areas until decades later. Another anomaly appeared in the communication systems. Throughout the underground station networks, engineers found what appeared to be signal transmission infrastructure. Not simple telegraph lines, but integrated communication networks with distribution nodes, amplification chambers, and what looked like automated message routing systems. Many were embedded in the walls themselves, positioned with geometric precision that made no sense for random wiring, designed with redundancy and network topology that resembled modern telecommunications more than Victorian-era telegraphy. It created an uncomfortable possibility. The railroad stations of the 1880s may not represent the beginning of coordinated rail transportation. They may be surface-level additions to something much larger, a transportation network whose subsurface infrastructure was never properly recorded, never officially acknowledged, and never explained in American railway history. The deeper the engineers investigated, the more impossible it became to dismiss these findings as construction anomalies. What emerged was evidence of systematic transportation planning, a complete network that extended beneath at least 60 documented stations across 6 states, possibly more. Here's where the story gets truly bizarre. In the months following the initial inspections, engineering teams catalogued over 4,700 distinct subsurface rooms and chambers within the station network, not counting surface-level facilities, 4,700 underground spaces with finished walls, ventilation systems, and apparent purposes related to passenger services. That number appeared in preliminary survey reports, but within a year it vanished from railroad company records. Published station documentation showed only standard foundation construction or typical basement facilities. The specific count of 4,700 chambers disappeared, almost as if someone decided that number raised too many uncomfortable questions. Because if American railroad stations truly had 4,700 finished underground rooms serving no documented purpose, who built them? Why were they abandoned? And most importantly, why does no transportation history acknowledge their systematic construction? As documentation accumulated, another pattern emerged. Despite being attributed to different railroad companies and different construction periods, all the subsurface facilities shared certain characteristics: standard room dimensions, consistent ceiling heights, uniform ventilation specifications. It suggested centralized planning, institutional standards, and coordinated construction across a massive project. This wasn't competitive railroad development. It was designed, possibly by a single administrative authority, with the resources to enforce building codes across an entire regional network. The physical artifacts recovered from the underground chambers only deepened the mystery. Inspection teams found manufactured items that didn't match any known American suppliers. Lighting fixtures using gas distribution, systems more sophisticated than anything frontier towns possessed. Ventilation grills with casting marks from foundries that don't appear in any industrial registry. Ceramic tiles with manufacturing precision that regional kilns supposedly couldn't achieve. Signage using typographic styles that don't match documented railroad company standards. Some installations appeared deliberately sealed when the stations were built. Walls constructed to block off entire sections. Passages filled with brick and mortar. Access points permanently closed, as if someone wanted to isolate the deeper levels from the operating stations above. Others seemed maintained briefly after station construction, showing signs of cleaning, minor repairs, then sudden abandonment. Perhaps most disturbing were the route maps found in certain underground chambers. Not maps of existing railroad lines, but network diagrams showing station connections that don't correspond to any known railway. Routes marked between cities where no tracks existed. Junctions indicated at locations that remained empty prairie. distance notations using measurement systems that don't match American or British standards, station designations with naming conventions that suggest a different organisational scheme entirely. Some researchers later claimed these were just planning documents for proposed routes that never materialised, but their finished presentation, formal drafting, and permanent installation in underground facilities suggests they documented something that already existed, a transportation network extensive enough to require standardised wayfinding systems. When you study the final months of the 1887 inspection programme, something becomes impossible to ignore. The documentation didn't conclude naturally. It was curtailed, not completed, not finished, stopped. The deeper the inspection teams went, the more the tone of their reports changed. Early entries were thorough, documenting dimensions, materials, and mechanical systems in detail. But by early 1888, the language becomes abbreviated, observations grow cursory, and entire station subsystems are marked not relevant to modernisation programme without explanation. And this is where the final mystery begins. Because the most sophisticated facilities, the most extensively developed subsurface networks, the most obviously designed passenger systems, these were the stations that were excluded from further documentation first. Engineers described being reassigned from certain locations, having access to lower levels restricted, being instructed to focus only on surface improvements without explanation. It wasn't gradual, it was immediate. The official explanation, budget constraints, modernisation priorities, focus on operational efficiency. But if it was only about efficient railroad operations, why were the stations with the most advanced subsurface infrastructure, the ones with complete environmental systems and intact underground facilities, the first to be excluded from inspection? And why were stations with obviously deteriorated foundations sometimes included in continued documentation? It doesn't make sense unless those sophisticated subsurface discoveries posed a different kind of threat, not an operational one, a historical one. Perhaps most telling is what happened to railroad construction records themselves. Station plans filed before 1887 sometimes show subsurface levels marked with notations like existing lower facilities or foundation structures to be incorporated. Plans filed after 1888 for the same stations show no such references. The underground networks simply vanished from official documentation. Even company histories changed. Railroad promotional materials published in the early 1880s occasionally mentioned extensive station facilities or multi-level terminal construction at specific locations. Publications from the 1890s describing the same stations reference only standard depot buildings and typical platform construction. The earlier infrastructure claims were systematically removed or minimized. Why was the most extensive evidence, the most sophisticated infrastructure, the most obviously designed network excluded from documentation? Because when you step back, the pattern becomes clear. The automated climate systems were omitted from records. The deep-level facilities were omitted from records. The 4,700 chambers were omitted from records. The subsurface terminals were omitted from records. The network route maps were omitted from records. And even portions of the photographic documentation vanished, almost as if the inspection program had accidentally revealed a chapter of American transportation history that wasn't supposed to surface. A chapter older than the Transcontinental Railroad, older than the locomotive age, older than the narrative we were given. The 1887 station inspections weren't just a railroad modernization survey, they were a glimpse, a brief accidental glimpse into a version of transportation infrastructure that raises more questions than answers. Because if America's railroad stations stand above extensive underground facilities built by engineers we no longer acknowledge, then the real question is not what was discovered in 1887. It's what else lies beneath the transportation hubs across the nation. What other stations, what other convenient modernization programs sealed evidence before anyone could map the complete systems? And why does railroad history need to forget 4,700 underground chambers? The answer might be simpler and more disturbing than any elaborate theory. Because acknowledging them would require rewriting everything we think we know about when advanced building systems became possible. Who possessed the organizational capability to construct such networks, and what transportation infrastructure existed before the age of steam locomotives? Thanks for watching, and if you found this interesting, well, there are a lot more stations with stories like this. Maybe I'll see you in the next one.